Here we're asked to find the sine of A. We recall SOH CAH TOA from trig, and I'm going to write it like this. You may have not seen it written this way, but I'll show you why, and some of you probably already know why I'm writing it this way. SOH CAH TOA, the S, the C, and the T stand for the sine, cosine, and tangent. So sine, cosine, tangent. And the sine is what we're looking for here. We're asked to find the sine of A. This O over H means opposite over hypotenuse. The A, as you recall, if we were looking for cosine or tangent, that would be adjacent side. But let's focus on the sine here. Opposite over hypotenuse. And it really matters if we're asked for A, B, or C because it's all about perspective and trigonometry. So from A, the side opposite of A is down here. We don't know it. We're going to have to find it. And the hypotenuse never changes. The hypotenuse is always the slanted side across from our right angle there. So that's 5. So we know already that we're going to have something over 5. Well, in order to find the missing link or the missing side of a right triangle, we use the Pythagorean theorem. And as you recall from your geometry class or algebra 2 or just last week's class, the Pythagorean theorem tells us the a squared plus b squared is c squared, where a and b are the legs, the shorter sides of the triangle, and c is your hypotenuse. So make sure you're putting it into the right spot. We don't know little a, that's our missing side. We do know b, that's radical 11. And then we also know c, which is 5, our hypotenuse. Awesome. All right, so a squared is just going to say a squared. Now the square root of 11 we have here, and then we're squaring it. So we took the number 11, taking the square root, and then squaring it. We're just left back at 11. Don't let that fool you. It's really easier than it looks. All right, we've got to subtract 11 from both sides. And then a squared is going to give us, it looks like 14. That's a squared, so when we square root both sides, we're going to get radical 14. Since 14 is not a perfect square, we're just going to leave it as the square root of 14 because that will give us some decimal answer. And as you notice in all your answer choices, there is a 14 in there. So we know that we have something right. So we're definitely going to have our opposite side length as radical 14 there. Awesome. Let's look and make sure this is an answer choice. Rad 14 over 5. It is. You can use SOH CAH TOA in order to answer these simple trig problems. You will definitely come across one, if not two, of these on your ACT every single time. And you just have to remember SOH CAH TOA.